Alright guys, this is a retake of question number 1. So what we have here, it says that double XYV is a parallelogram in which V to Y is represented by A and V to W is represented by B. Now it says S is a point on WY. Alright, so here we have a diagram and it's a parallelogram. Alright, so they're saying that S is on a point WY. So this is WY and it's S, such that W to S and S to Y is in the ratio of 1 to 2. Alright? Okay. So we can, well, let me just go back up here. This and that this figure here is a parallelogram. Right? So we know that these two sides will be parallel. So if VY is represented by A, then double X is also represented by A, since these two lines are parallel. And if VW is represented by B, also YX would be represented by B. Alright? Alright, let's go back to the ratio. Now it says double S to SY is in a 1 to 2 ratio. As you can see, SY is twice the length of double S. Alright, but algebraically we can also see that it takes two double S's. Alright, so if you could fit in two double S in SY, you will get one SY. So algebraically, two double S will give you one SY. Alright, which is also to say that double S is a half of SY. We could also look further to say that you could actually fit in three double S's. So three double S would give you one WY. So algebraically, three double S will give you one WY. Or you could say double S is 1/3 of WY. Alright? So we can interpret all of this from this ratio. Alright, so let's proceed to the question. It says, write in terms of A and B. Now, when it says A and B, they're talking about this A and this B. So we can represent a vector using this A and this B. So write in terms of A and B an expression for A, WY. Alright, let me go back up here. An expression is something without an equal sign. Alright, okay, so WY. How do we go from W to Y? We go from W to V and V to Y. Alright, so the vector equation for WY is W to V plus V to Y. Now, V to W is represented by B. But if I have W V, you would get negative B, because this would have been the inverse of that vector there. Alright, so WV is actually negative B, and VY is just VY, which is A. So the answer is negative B plus A. Okay, next question. Write in terms of A and B an expression for WS. Alright, now WS from what we deducted from the ratio, we said that WS is actually what? 1/3 of WY. I chose to use this because we know what WY is. We just worked out. All right. So WS is actually 1/3 of WI. So that's going to be 1/3 of negative B plus A. And we use the distributive property to get this. So this is our answer. I must remind you in vectors, we always use the previous question to get the other question. All right, part C. How do we go from S to X? Let's go to the diagram. So SX. All right, so the best route is from S to W, W to X. All right, and you might be wondering, but sir, I could have gone from S to W, W to V, V to Y, Y to X. Two reasons. That's a longer route. All right, and you know, the more working out, the more errors you're probably gonna make. So S to W, W to X is the shorter route. So SX is S to W plus W to X. Now WS is this expression, all right? But SW, which would have been the inverse of WS, would have been equal to this, right? So the negative 1/3 becomes what? Positive 1/3 B, and the plus 1/3 A becomes negative 1/3 A. So all of this is SW. So this in bracket here is SW plus WX. Now we said that this diagram is a parallelogram. So if VY is A and it's a parallelogram, then WX is also A. So that's why WX we have here is plus A. And when we simplify all of this, grouping the A's together, we end up with this for the answer. So this is the answer for what S to X in terms of A and B would be. All right? Okay. Let's go to part 2. Now, part 2 says that R is the midpoint of VW. All right? Now, this is VW, and what they're saying that in the middle of VW is what we have here is R. All right? And R is the midpoint of VW. Now, when I say that R is the midpoint of VW, what I get from that is that RW is going to be a half of VW, or VR is a half of VW. All right. Now it says R is the midpoint of VW, and we established that this equation is important. And it goes on to say that prove that R, S, and X are collinear. All right. Now this is R, this is X, and this is X. Sorry, this is R, S, and X. So what they're saying that if you're to draw a straight line, what they're saying that these 3 points lie in a straight line. So that's what collinear means. All right. Now we need to prove. How do we prove collinear? Well, we need to prove that R to S is parallel to S and X. That's what we need to prove. How do we prove something is parallel? If we can find a scalar multiple of the other vector. Alright, so having said that, let us compare RS and SX. But hold on, don't we know what SX is? Yes, we just work on SX. SX is this expression here, naturally. So all we need to do is find what? RS. Alright. So how do we go from R, which is right here, to S? The shortest route is going from R to W and then W to S. Alright, so RS is R to W and W to S. But you remember that we told you that R is a midpoint of VW? So RW